So on US EVA 23, EV2, Luca Parmitano will egress the airlock first. He'll be wearing the pure white suit. He'll bring out a bag containing some cables that he'll be installing during the EVA, and then attach his own and Chris's safety tethers outside the airlock. EV1, Chris Cassidy, wearing the red striped suit, will egress and retrieve 2 more large bags from the airlock. One contains the 4 radiator V-guides, and the other is an empty bag in which he'll stow the main bus switching unit multi-layer insulation towards the end of the EVA. Chris will translate up over the airlock and across the top of the Z1 truss, and then down to the port side of Z1, where he will work on the second of the 2 Y bypass jumpers, and this one will have been temporarily stowed on the previous EVA, as Ernie mentioned. He'll be working with the upper cables in this view, and what he's actually going to do is swap 2 connectors. In this graphic here, the 2 connectors indicated by the double-headed arrow will swap, and then the 2 connectors in the blue circles will swap. And in the end, then, the green cable will have been replaced by the Y bypass jumper in red, which provides powers from 2 different sources. Meanwhile, Luca will take his bag of cables from the airlock and translate under the Unity node. He'll go to its upper aft end cone, where he'll temporarily stow that bag, and you can see the 2 handrails. He'll stow it between blinking here. Then he'll retrieve the multi-purpose laboratory module Ethernet cable from the bag and translate to the forward end cone of Unity, where he'll connect the cable to a spare Ethernet connector that is located in the corner between US Lab and the Unity and Tranquility nodes. Luca will lay the cable out as he translates back aft towards the Russian segment, and he'll be restraining the cable onto handrails and other structure using EVA wire ties. This MLM Ethernet cable actually includes 4 additional extra connectors on its forward end that can be used for future Ethernet expansion capability. When Luca reaches the forward end of the Zarya Russian module, he will tie off the end of the cable on a handrail, where a Russian crew will complete the connection to a cable they will route later this year during a Russian EVA. After Chris finishes with the Z1Y bypass jumper, he'll return to the airlock to retrieve the large bag containing the 4 V-guides. And he'll head out over the lab and out to the port 1 or P1 truss. You can see the translation path he'll be taking highlighted by the handrails blinking there. And then he'll go down to the nadir side, or the bottom side of the truss, where he and Luca installed one of the radiator grapple bars on the previous EVA. Once he's there, he'll bolt the 4 V-guides onto stowage brackets attached to the grapple bar. And like the grapple bars, the V-guides, each one has 2 bolts that zip into the nut first, and then the EVA power tool or pistol grip tool is used to provide the final torque. While Chris is working with the radiator V-guides, Luca will continue with several tasks to finish the outfitting of the power and data grapple fixture, or PDGF, on the Zarya module. And first, he's going to be checking for a misconfigured grounding wire inside one of the connector doors, which you see blinking here. Mike Fossum actually cleared one of the connector doors on STS-135. You can see that one in the upper right photo with the little white wire that's poking out of the door there. But the yellow arrows point to a couple little white dots that we can see behind the other door. And we think that although Mike inspected it and it appeared clear, it's possible that the door just pushed that wire out of the way. So in this video, you can see what Luca will have to do is peel back the multi-layer insulation around the PDGF, and he'll use the large hook from his waist tether in order to open the connector doors so he doesn't have to stick his fingers inside there. And he'll do an inspection to see if he sees anything. But then because the door may have actually pushed that wire out of the way, we will locate it. It's a grounding wire for the multi-layer insulation, and just gently pull it out, make sure there's no loose wire inside that connector cavity. And he'll twist it around to keep it out of the way, and then restrain it in place by putting the multi-layer insulation back, and it's just attached with Velcro. And then he'll do one final look inside the connector to make sure everything looks clear. Once he's complete with that task, Luca will release a short segment of the data cable for the PDGF and route it forward onto the pressurized mating adapter. This one's actually attached to the PDGF already. and he'll attach that to a handrail on the PMA. Then he'll return to his cable bag and retrieve the 1553 data cable, which he will attach to that short pigtail. And this actually uses Russian-style connectors on those two cables there. And then he'll route the cable across the pressurized mating adapter over to a connector panel on the Tranquility node. And the 1553 cable is actually a pair of cables that have been taped together just to make them easier to route by EVA, and it provides 2 data channels for the PDGF. So after Luca has connected the 2 cables, the ground will do a quick check to verify good communication on both channels. While that's being done, Luca will clean up his work site and retrieve the cable bag. He'll stow that in the airlock and then translate out to meet Chris at the P1 truss for the wireless video system external transceiver assembly, or WETA, antenna relocation task. So this is on the zenith side, just above where Chris was working on the V guides. And the crew will work together to demate 3 connectors from P1 and then release a single large bolt that holds the antenna stanchion to the space station. They'll position the WETA and its stanchion on Chris's body restraint tether and retrieve their tool bags, and then they will carefully together translate down towards the Node 2 Harmony aft end cone. You can see the translation path they'll be taking. And we have them do this together just because the antenna is very large, and so it helps Chris to make sure that it doesn't get bumped into anything along the way. Once at the Harmony's upper aft end, they'll return the antenna to a vertical position and drive the bolt to secure it in the Harmony module. You'll see the Neutral Buoyancy Lab footage of them working with this antenna, and it's about 7 feet long. So it's also one of the 3 antennas that provide our helmet camera video during spacewalks. When this antenna is installed, the crew will then remate the 3 connectors to a connector panel on Harmony, and which provides power to the antenna as well as the video signal back to us. And then they'll retrieve their tool bags and return back to the airlock. Chris will stow the bag that carried the V-guides and retrieve the large empty bag for the main bus switching unit multi-layer insulation. And then he will be heading out to the Express Logistics Carrier number 2 on the zenith side of the starboard 3 truss. You can see his translation path here. And you can also see the alpha magnetic spectrometer AMS right next to that work site. This is the current location of the failed main bus switching unit that was changed out on US EVAs 18 and 19 in August of 2012. And Chris will be removing a large insulation blanket from the MBSU. He'll stow it inside of his bag, and then he'll use some EVA wire ties to restrain the flaps around the perimeter of the MBSU so they don't get in the way of robotic interfaces, and it can be brought inside robotically, as David mentioned earlier. During this time, Luca will either be finishing up the PDGF tasks he was working on earlier, or he may assist Chris in completing the blanket removal tasks and taking additional photos of the AMS. And that's the end of the planned timeline. We do have some get-aheads. A key one is the replacement of the camera on the forward corner of the Japanese experiment module exposed facility. Chris Cassidy actually installed this camera on his previous shuttle mission, so he's very familiar with that work site. And then the crew will return to the airlock. They'll stow their hardware, including the radiator grapple bar FSC bag that was left outside from EVA 22 and ingress, and that will be the end of EVA 23.